So here I'll summarize the second question. In the drawing we have a quarter circle inside this quarter circle we have a circle and a semicircle that are tangent to each other at point H, and our mission is to find out the shaded area. Okay? So in general it is very easy to see that the shaded area equals to the area of the quarter circle minus the area of the circle minus the area of the semicircle. Okay? So first of all we have to find out the radius of the quarter circle in order to find out the area of the quarter circle. Okay, so here because of the fact that this is a quarter circle, then it means that this point is the center of the quarter circle and this angle equals to 90 degrees. Okay? And we defined the center of the circle as point P. So here we have tangent OB that is tangent to the circle at point M. Point M is the point of tendency of tangent OM in this circle. And we have the radius PM that is drawn to the point of tendency, and whenever you have a radius that is drawn to the point of tendency, then tangent OM will be perpendicular to the radius MP. So if OM is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So, okay. Then from point P, that is the center of the circle, we draw perpendicular on NO. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So here we created quadrilateral OLPM that has 1, 2, 3 right angles. So in quadrilateral LPOM we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees. Okay? So 270 degrees plus the size of the fourth angle that is actually angle LPM, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we subtracted 270 degrees from this equation. We found out that the missing angle LPM equals to 360 degrees minus 270 degrees. It is equal to 90 degrees. So this is a right angle. It is equal to 90 degrees. So actually we found out that inside quadrilateral LPOM we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral LPOM as a rectangle. Okay? And we also know that the opposite sides of a rectangle are equal to each other. That is to say, LO equals to PM. LO equals to PM according to the rule that the opposite sides of a rectangle are equal to each other. But we have already found out that PM equals to 2. This is the radius of the circle. So from this equation 2 equals to PM equals to NO, we will derive that NO also equals to 2 units. Here NO equals to 2 units. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that LP equals to OM. LP equals to OM, and if we define OM as X, yeah, OM equals to X, then from this equation X equals to MO equals to LP, we will derive that LP also equals to X. Here LP equals to X. And here we have internal lunge between the circle and the quarter circle, that is to say they are touching each other internally at point K. Point K is the point of tendency, or the touching point, or the common point of the circle and the quarter circle. Whenever you have an internal lunge between two circles or two circular shapes, then the straight line that joins the center together must pass through the point of tendency, or through the common point, that is point K. In our case, the center of the quarter circle is point O. The center of the semicircle is at point P, and the straight line that connects the two centers together is OP, and according to the rule that I mentioned, the straight line OP must pass through point K, that is the touching point of the circle and the quarter circle. So actually, we found out that line segment OPK is the one straight line. According to the rule that I mentioned, line segment OPK is one straight line, or we can also say that points O, P, and K, they are all located on the same straight line. This is the same thing that I expressed in two different methods. Okay, OPK is a straight line, so if OPK is a straight line, then OK is also a straight line. OK is a straight line. Point O is the center of the quarter circle. Point K is the point on the quarter circle itself. Therefore, OK is the radius of the quarter circle. Okay? Because this is exactly the definition of a radius. OK is the radius of the quarter circle. So we define the radius of the quarter circle as capital R. So according to our definition, the radius of the quarter circle that is equal to OK, it is equal to capital R. Okay, here, OK equals to capital R. And there P is the center of the circle, point K is the point of the circle itself, therefore PK is the radius of the circle that is equal to 2 units according to what is given as the question. So in conclusion, I found out that OK, that is the radius of the quarter circle is equal to capital R according to our definition, and PK, that is the radius of the circle, equals to 2 units. And what is the length of OP? The length of line segment OP, it is equal to OK minus PK. Again, OK minus PK equals to OP. OP equals to OK minus PK. OK equals to capital R, and PK equals to 2. So in conclusion, we found out that the length of line segment OP equals to R minus 2. Here, OP equals to R minus 2. Now, we implemented the Pythagoras theorem on the right triangle OPM. We copy the right triangle OPM here, and we implemented the Pythagoras theorem on this right triangle OPM. The hypotenuse OP is R minus 2, PM equals to 2, and OM equals to X. So according to the Pythagoras theorem, PT is a abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OP, and the square of the hypotenuse is OP squared. That is equal to that is equal to the sum of the squares of the perpendiculars, that is to say it is equal to PM squared plus MO squared. So in conclusion, we found out that according to the Pythagoras theorem, OP squared equals to PM squared plus MO squared. OP equals to R minus 2, so OP squared is R minus 2 squared, and PM equals to 2, so PM squared is 2 squared, that is 4, plus OM squared. OM equals to X, so OM squared is X squared. So in conclusion, we found out that according to equation number 1 and according to Pythagoras theorem also, we found out that R minus 2 squared equals to 4 plus X squared. Here we open the brackets on this side of equation number 1, and we found out that R minus 2 squared equals to R squared plus 2 squared, that is 4, minus 2 times R times 2, that is minus R. So on this side of the equation we have R squared plus 4 minus 4R. In the other side of the equation we have 4 plus X squared. So here we have 4 on both sides of equation number 1, so 4 we get cancelled. And what is left from equation number 1, after we cancelled 4, what is left here in this side of the equation we have r squared minus 4r. In the other side of the equation, we left only with x squared. So according to equation number 1, we found out that x squared equals to r squared minus 4r. Okay, then we focus at this point H, that is the point of tendency of the semicircle with the circle. So here we have an external length between two circular shapes. Whenever you have an external length between two circular shapes, then the straight line that connects their centers together must pass for the point of tendency, or for the point of, for the touching point, or for the point of tendency, or for the common point of the two circular shapes. Point P is the center of the circle. Point N is the center of the semicircle. And the straight line that connects the two centers together is NP. So this straight line NP must pass for point H, that is the point of tendency of the circle with the semicircle. That is to say, we actually found out that NHP is one straight line. Okay, so we found out that PHN or NHP is one straight line. We can also say that points N, point H, and point P are all located on the same straight line. It is the same thing, like saying that PHN is one straight line. So if PHN is one straight line, then PN is also one straight line. Is a straight line, so PN is a straight line. And what is the length of PN? PN equals to NH plus HP. Here, PN equals to NH plus HP. NH equals to 2 units, and HP also equals to 2 units. So in conclusion, we found out that NP equals to NH, that is 2, plus P plus HP, that is also 2. So in conclusion, NP equals to 2 plus 2, that is 4. So the hypotenuse NP equals to 2 units. So I copied the right triangle, then actually found out the length of side NL. What is the length of side NL? The length of side NL, it is very easy to see from the drawing, that is equal to the radius of the quarter circle, that is equal to OY minus YN minus LO. I repeat again, that the length of line segment NL equals to YO, that is the radius of the quarter circle, minus NY minus LO. Minus NY minus LO. In conclusion, found out that the length of line segment NL equals to YO. YO is the radius of the quarter circle, that is equal to capital R according to our definition. Minus NT minus YN, and YN equals to 2, minus LO, LO is equals to also 2. So in conclusion, found out that NN equals to capital R minus 2 minus 2, and capital R minus 2 minus 2 equals to capital R minus 4. So here, NL equals to R capital R minus 4. So I copied the right triangle NLP in this new page and implemented the Pythagoras theorem on this triangle, the right triangle, triangle NLP. We have already found out that NN equals to capital R minus 4, LP equals to X, and the hypotenuse NP equals to 2 plus 2, that is 4. Then we implemented the Pythagoras theorem on the right triangle, triangle NLP by PT's information for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, the hypotenuse is NP. So the square of the hypotenuse is NP squared. It must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to NL squared plus LP squared. So in conclusion, according to the Pythagoras theorem, we get that NP squared equals to NL squared plus LP squared. NP equals to 4, so NP squared is 4 squared, that is 16. And it is equal to NL squared. NL equals to R minus 4, so NL squared is R minus 4 squared plus X squared. X squared plus LP squared. LP is X, so LP squared is X squared. So in conclusion, here, NP equals to 4, so NP squared is 4 squared, that is 16, and N equals to R, so N squared is R minus 4 squared and LP equals to x, so LP squared is x squared. So in conclusion, according to equation number 2, we found out that 16 equals to r minus 4 squared plus x squared. Here we open the brackets on this side of the equation and we found out that 16 equals to r minus 4 squared. R minus 4 squared equals to r squared plus 4 squared, that is 16, minus 2 times r times 4, that is minus 8r plus x squared. Here we have 16 on both sides of equation number 2, so 16 will get cancelled. And we left only with 0, that is equal to r squared minus 8r plus x squared. Here we added r squared to this equation, equation number 2, and we found out that actually here we subtracted r squared. First of all, we added 8r to this equation, equation number 2, and we found out that 8r equals to r squared plus x squared. Then we subtracted r squared from this equation, equation number 2, and found out in conclusion that according to equation number 2, x squared equals to 8r minus r squared. So we have two different expressions for r squared. I wrote down together both expressions. According to equation number 1, x squared equals to r squared minus 4r, while according to equation number 2, we found out that x squared equals to 8r minus r squared. Then we created equation number 3 that states that x squared according to equation number 1 must be equal to x squared according to equation number 2. So according to equation number 3, we found out that x squared according to equation number 1 is r squared minus 4r. It must be equal to x squared according to equation number 2, that is equal to 8r minus r squared. Here we added r squared to this equation, equation number 3, and we found out that r squared plus r squared is 2r squared, so 2r squared minus 4r equals to 8r. Here we added 4r to this equation, equation number 3, and we found out that 2r squared equals to 4r minus 4r is 0, and 8r plus 4r is 12r. So in conclusion, we found out that 2r squared equals to 12r. Here we divided equation number 3 by 2, and we found out that 2r squared over 2 is r squared, and 12r over 2 is 6r. So in conclusion, we found out that according to equation number 3, r squared equals to 6r. Here we subtracted 6r from this equation, equation number 3, and we found out that r squared minus 6r equals to 0. Here we took r as a common factor from this equation, equation number 3. So what is left from r squared after we took from it r as a common factor? What is left? It is actually r. And what is left from minus 6r after we took from it r as a common factor? What is left? It is actually minus 6. So in conclusion, we found out that according to equation number 3, r times r minus 6 equals to 0. So here we have two solutions that are possible for r, for capital R. The first solution is that capital R equals to 0, but because of the fact that capital R is the radius of the quarter circle, it can never be equal to 0. It must be a length, it must be a positive number. So we cancel this solution. R equals to 0 is cancelled, and we left only with the second solution, that r minus 6 equals to 0. We added 6 to this equation and found out that r, capital R, that is the radius of the quarter circle, equal to 6 units. Now we can find out the area of the quarter circle. When we know the radius, it is very easy to find out the area. And what is the value of the shaded area? The shaded area equals to the area of the quarter circle minus the area of the circle minus the area of the semicircle. And the area of the quarter circle is pi r squared over 4. It is the area of the circle over 4. Okay? What is the area of the circle? Is pi r squared. R equals to 2, so it is pi 2 squared. What is the area of the semicircle? R also equals to 2, so it is pi r squared over 2, or pi 2 squared over 2. And we just right now found out that capital R equals to 6, so pi r squared is pi 6 squared, that is 6 squared is 36. So in conclusion, found out that the area of the quarter circle equals to 36 pi over 4 minus the area of the circle, that is 4 pi, minus the area of the semicircle, that is 2 pi. 36 over 4 is 9, so in total this expression equals to 2 pi, that is the area of the quarter circle. minus the area of the circle that is 4 pi, minus the area of the semicircle that is 2 pi. So 2 minus 4 minus 9 minus 4 minus 2 is 3. So in conclusion, 2 pi minus 4 pi minus 2 pi is 3 pi. So in conclusion, we found out that the shaded area equals to either 3 pi square units, or in terms of numbers, it is equal to 9.42 square units. Okay, thank you very much.